Boom! Yes folks, Hume again. In this video we're continuing with our series on different topics in mathematics. This video is the first in a short series on trigonometry. So going back to the video that we did on Pythagoras theorem, where we would have adopted a particular labeling convention where the triangle is concerned, the right angle triangle that is. We're going to just revise that briefly at the beginning and then go straight into the aspect of trigonometric ratios. Very important. This is the right angle triangle we're talking about. So you have a right angle, you must have this little box in the corner or some other indication that that is a right angle. Otherwise, don't assume that the angle is a right angle. You have your theta here and you have your phi here. Alright, just like you have x and y in your regular algebra. When we're talking angles, we're talking theta and we're talking phi. If this is a right angle, of course, it means that these two angles must add up to 90 degrees. The reason for that being that the sum of all the angles in any triangle is 180. So if you have a right angle triangle where this one angle alone is 90 degrees, then the sum of these two angles is 90 degrees. So this angle plus this angle is 90 degrees. So therefore, theta plus phi is equal to 90 degrees. Must keep that in mind. As simple as that is, sometimes people miss that in the course of a question. And because they miss it, they run into all kinds of trouble that they no need to get themselves into. So, now that we have this, notice the extra labeling on this triangle now. You have A, B, and C. These are the points of the triangle, right? The vertices, so to speak. Vertices, of course, being the plural of vertex. Now, notice I would have adopted a particular convention where the direction is concerned, right? Now, the convention that I learned when I was doing this in school is to label your points anti-clockwise, starting from this corner at the bottom here. So I would normally go A, B, and C, right? I see in some instances now people labeling it A, B, C. At the end of the day, it really doesn't matter which direction you choose to label your points, your vertices. However, for my purposes, I will stick to the convention that I know, which is anti-clockwise. Good? So don't make that a problem. Don't make that a point of contention. That's one of those details that, whatever. Alright, so we continuing. So let us start with the angle phi. Alright? Remember, we spoke about the reference angle, and remember, we touched briefly on the fact that in a right angle triangle, you can have this theta as the reference angle, or you can have this phi as the reference angle. So what I'm going to do is go through the first set of explanations with reference to theta, and then we'll switch to phi, and then we'll do some little magic inside it. So remember that your labeling of your sides is done with reference to the angle. So if this is the reference angle here, then let us see. Then this here would be the side opposite to your reference angle. This is the side adjacent next to your reference angle, and of course, the hypotenuse is always the hypotenuse. Now here is where we start to describe the ratios. I'm going to talk about it in general abstract terms, and then I will use particular examples to drive the point home. So if you don't get it at the abstract phase, don't be dismayed. I would encourage you to stick with it, continue looking at the video. Even if we go into the second video to do the examples, stick with it. It will be worth it. So many years ago, however many years ago, right, there's a lot of debate about whether it was the Egyptians or the Babylonians or the Greeks who first encountered trigonometry, discovered trigonometry, whatever, right? At this stage of the game in 2020, there's no real way for us to be absolutely sure. What we do know, however, is that somewhere over the course of history, various persons would have discovered that there are certain properties that are inherent in any right angle triangle. Alright? So that's the first thing we have to understand. It's about properties. It's about something that you come and meet there. You didn't create it, you didn't make it. You just notice that all the right angle triangles have these particular properties. So in the same way, we have the Pythagoras theorem, where the square of the hypotenuse is equal to the square of one side plus the square of the other side. That is a particular property that day. The same thing happens when we start to talk about angles, and then we get into ratios now. So what we realize is that when you have any angle theta here, this side over this side is a particular ratio that is always the same once you have any particular angle. Don't worry about the convoluted vocabulary. All right, same thing here. The ratio of this side to this side is always the same, and likewise the ratio of this side to this side is always the same. So in other words, once this angle doesn't change, the length of the sides doesn't matter. What matters is the ratio of the sides, the ratio of the length of the side. We will get into that in a little more detail when we actually do the examples. So over time, we adopt certain conventions where the naming of these ratios is concerned. So if we're talking about theta, we could say then that why they call it sine, I can't say that I could give you a proper answer to that. We just know that somebody decided to call it sine, and that is what we have. So the sine of this theta here is equal to your opposite over your hypotenuse, right? So your sine theta is equal to the ratio of the opposite side over the hypotenuse. All right. The cosine, shortened form as cosine, cos, is opposite. Sorry, the cosine is adjacent over hypotenuse. All right. The cosine is adjacent over hypotenuse, and then we have the tangent, what we refer to as tan in the shortened form, is equal to your opposite over your adjacent. Alright? Now as I say, we don't know why they call it cosine, we don't know why they call it tan, but that is what it is, and that's what we're going with. So in other words, they looked at each of the three ratios. If you have three sides, you could only have three possible ratios where you're looking at the ratios of two sides. So you have all three ratios of the right angle triangle. This is the naming convention. Alright? So we're gonna wind up this video by getting into a familiar place. What is that familiar place? Most people, as soon as you talk about trigonometry, you talk to the average Form 3 or Form 4 student. As soon as you start talking trigonometry, hear them. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Right? What does SOHCAHTOA mean? A lot of people don't know. If you ask them to explain what it is about, they can't tell you. But they know what SOHCAHTOA is. Good? So here what? You have SOHCAHTOA, S-O-H, you have C-A-H, and you have T-O-A. Alright? Now there are all kinds of different songs and rhymes and poems that people use to memorize this, right? So S-O-H refers to your S here is your sine, your C here is equal to your cosine, and your T is your tangent. So the sine is opposite over hypotenuse, opposite over hypotenuse. The cosine is adjacent over hypotenuse, adjacent over hypotenuse, and the tangent is opposite over adjacent. Alright? So SOHCAHTOA, use that if it works for you. If that doesn't work for you, then you're always free to use something else. The bottom line, however, is that you have to know what the ratios are. Fortunately, in most exams across the world, you wouldn't have the burden of necessarily having to remember the ratio. What I mean by that is simply that they will give it usually in the formula sheet. So if for some reason you forget what the sine of an angle is, or you forget what the cosine of an angle is, or you forget what the tangent of an angle is, you just flip to the front, use the formula sheet, and then you proceed with working the problem. Of course, if you take your practice seriously, by the time you get to the exam, you wouldn't have the problem of not being sure what's cosine and not being sure what's sine. That is another common problem. People get a right angle triangle and they're not sure which ratio to use, whether to use sine or whether to use cosine. Yeah? So all of that will be taken care of by paying the proper attention to your preparation. Good. So you're gonna wind up this video now. In the next video, we're gonna bring the thing, make it come alive by using actual concrete examples, common simple examples of trigonometric ratios with angles that we are aware of and angles that we know. Good. So that's it for now. Take care and look out. Plenty more coming your way.